Hey guys, this is Matt with Fablicator, and in this video I'll go over the features of the SX 3D printer and explain how to print a G-code file from start to finish. In the process, I'll cover all the information you'll need to know in order to use your printer. The Fablicator program is what you'll use to interface with the printer. It can be opened from the desktop or the taskbar below. Inside, you'll find the current temperatures of the nozzle and the bed being recorded in the lower left-hand corner. Just above that are the temperature controls. The rows are each labeled, one for extruder temp and one for bed temp. These are for heating the nozzle and the bed when the printer is idle in between prints. A temperature can be chosen in the drop-down menu, and the set and off buttons can be used to turn them on and off. Manual temperature settings are overwritten when a print is started because a G-code file contains temperature information which the Fablicator program will use. The extrude and reverse buttons control the flow of filament. The nozzle must first be heated in order to use these controls, and they will only work when the printer is idle. Above that are the controls for the axes of the printer. Each time the Fablicator program is opened, the printer must first be homed using this button here before any of the axes are moved manually using the program commands. This gives the program a starting position for keeping track of where they each sit and prevents any of the axes from being driven beyond their limits. The axes are homed automatically before a print begins when the print button is pressed. Within this circle are the controls for the X and Y axes. You can use these buttons to move them by the corresponding number of millimeters. The controls for the Z axis are along the right side here. Additionally, each axis can be homed individually using these buttons around the circle. To the right of the controls, this window will display your current print and its progress. And below that, you have a graph which monitors the temperatures of the extruder and the bed over time. It is important that none of the settings above here are ever changed, as well as the settings contained within the options. These are set by us, and changing them will disrupt the proper functioning of your printer. On the SX, filament is driven down into the nozzle, where it is melted and continues through onto the heated bed to build a printed part. The nozzle, of course, gets extremely hot, so be very careful not to burn yourself on the heated nozzle. The fan in front of the nozzle works to hold a constant temperature within the nozzle itself, so it is important that the fan is never obstructed and remains running. To get started installing the filament on the machine, we'll use the Fablicator program to heat the nozzle. For that, we'll use the extruder and bed controls located at the bottom left-hand corner of the program. From the drop-down menu of the extruder controls, choose 210 degrees Celsius, since we'll be using a PLA filament, and then hit Set. You will immediately see the extruder temperature begin to rise. While that heats, we'll take the spool holder from the startup kit and install it on the side of the machine. To install the spool holder, simply clip its front arm into the corresponding void in the frame of the SX. You can then slide your spool of filament onto the holder and add the clip which slides onto the end. The filament spool should always be able to spin freely on the holder. At this point, you can bring your filament up to the nozzle. You may have to clip the end of the filament so that you have a straight tip to send down into the nozzle. And you'll want to feed the filament down through the piece above the nozzle with the yellow arrow and set it on the filament driver, which sits just above the upper opening of the nozzle itself. Now, as long as the nozzle is heated to the full 210 degrees, you can come up just above the extruder temperature controls and hit the button that says Extrude. This will activate the driver and send the filament down through the nozzle. By the time it is finished extruding, you should see the filament coming through the nozzle. You can then hit off to turn off the heat to the nozzle. When changing over from a different filament, heat the nozzle and then use the reverse button right next to the extrude button to remove the original filament before feeding the new one in. The disable switches are located on the right side of the front panel of the SX. The top one, labeled XYZ, disables the motors that control the axes of the printer, allowing you to move them by hand. This will also stop all movement of the axes mid-print, so it can be useful to prevent damage to your machine in the event of a failing print. The lower disable switch, labeled EXT, disables the motor controlling the filament driver. This allows the drive wheel to spin freely. This allows you to install filament by hand when the nozzle is not heated. Also on the front of the machine is the button controlling the lights inside the print area. Pressing this will turn on and off the two strips of LEDs. The SX printer has a heated print bed, which enables printing with a variety of filament types, and improves print quality by preventing parts from warping as they print. In order for parts to stick to the glass bed, we apply the primer solution. Primer solution is made up of ABS pellets, which are dissolved in acetone in the provided glass bottle. To make the primer solution, an entire bag of ABS pellets is emptied into the primer bottle. Then acetone is added to the bottle until it is almost full. For this, we use a glass baster. Acetone will dissolve many materials, so glass must be used. 100% pure acetone must be used for this, which can be bought at any hardware store. It is also important to note that acetone is a flammable liquid and should be dealt with carefully. This is then allowed to sit for 12 to 24 hours until the ABS pellets are fully dissolved. When applying primer solution, make a small pool by filling the eyedropper and then emptying it on the center of the bed several times. Acetone is a very strong solvent and will cause damage to surfaces, so special care should be taken to not get it on the computer case below or anywhere else besides the bed. You can then use a clean paper towel to spread the primer across the entire bed, making sure to cover each corner. For the best results, this should be done between every print when the bed is cooled to room temperature. For information on creating your own G-code file from an STL file, reference the KissSlicer Basics video, which we also provide. For this video, I'm going to print one of the pre-sliced G-code files that come loaded on the desktop of the SX. To find it, go into the folder titled Sample G-code Files, then double-click on PLA. I'll be using the 6-inch roller G-code file within this folder. To load the G-code within the program, simply double-click on the file. Alternatively, you may click on the button labeled Load File within the program, or go to File, Open, then choose your G-code file. Once your G-code is loaded within the program, you will see the file name appear along the bottom of the window, and an image of your design may appear in the view window. This preview image will sometimes be delayed in appearing, but your print can be started as long as the file is loaded within the program. All you have to do then is press print. The axes of the printer will home and then the nozzle will move down to the front left-hand corner of the bed as the extruder and the bed heat. When they reach full temperature, your print will begin. It is important to note that the bed and nozzle temperatures cannot be changed here while a print is taking place. For example, you cannot start a print that is meant for PLA filament and then alter the bed temperatures to ABS using the drop-down menu. A G-code file that has been sliced for ABS temperatures must be used if you intend to use an ABS filament. As your print gets further along, you will notice this green bar climbing along the right side of the view window. This tracks the completion of your print and corresponds to the percentage appearing at the bottom here. As I mentioned earlier, the axes of the printer can be stopped mid-print using the XYZ disable switch. This can sometimes be necessary if a print has been started with incorrect filament type settings, or if anything otherwise is noticed to be going wrong. However, the print must then be ended within the Fablicator program as well. Along the top left side of the program, you will find a button labeled Disconnect. Pressing this will cause the printer to stop receiving information from the computer and halt your print. You would then have to hit the same button again to re-establish a connection. At that point, you can home the axes of the printer using the Home button. As the green bar reaches the top of the window, your print will complete. At that point, the X and Y axes will home, and the Y axis will come forward to the front of the machine. It is important that you allow the bed to cool before prying your completed part from the bed. This cooling allows the plastic to naturally release from the bed. It is best to let the bed cool to around room temperature, which should only take about 10 minutes. At that point, use the scraper tool provided in your startup kit to peel the part up from the bed. Slowly work your way around the edges of the part with the scraper until it releases. You would then want to clean up any debris left behind in the print space, including this strip of plastic along the left side of the bed. Most filament can be left on the side of the printer as long as you are not in a high humidity environment. The exceptions to this are PVOH and nylon filaments. You will sometimes end up with filament buildup on the nozzle. The brass brush provided in your startup kit is meant for the purpose of cleaning this filament buildup off. The nozzle must first be heated to full temperature, then the brass brush can be used to gently brush off the filament from the nozzle. Special care should be taken around the wires on the left side to not damage them. You'll then want to clean up all the plastic that fell from the nozzle into the print space. Primer solution may be reapplied over top existing primer in order to start a new print. It will eventually build up excessively over a long period of time, at which point the bed will need to be cleaned. The bed cleaning process is covered in our printer maintenance video. Thank you for watching this video. Please feel free to contact us with any questions or concerns about your 3D printer.